All right, everybody, welcome back. Today we're going to be talking about SQA5, which is solve by factoring and square roots. This is really a combo platter of everything we've been working on so far. We kind of just put it all together and package it up into one nice package where we use all of our skills at once. So in this first problem, it says use the zero product property to solve. This is how we solve these in any problem where we are being asked to solve by factoring, right? This is what is the hinge of this whole thing. In this problem, we have two numbers, or two mathematical ideas, 3x and x minus 7, that are being multiplied together and they equal 0. That equaling 0 is probably the most important part, because if they equal 0, there's only two ways that that can happen. Either this one equals 0 or this one equals 0. So what we do is we just set up two simple equations. 3x equals 0 and x minus 7 equals 0, and then we just need to solve. So to solve the first one, we would divide both sides by 3. 0 divided by 3 is just 0. And then in the second one, we're going to add 7 and add 7, and I'll get x is equal to positive 7. And then these are going to be our two answers for this problem, right? It's really, that's what we call the zero product property. Now, the nice thing about doing the zero product property is we don't have to do the factoring stuff first, but that will come a little bit later. So here's another problem. In this one, we have three things that are being multiplied together. 6, x plus 3, and let's do a better color. How about x minus 4? Those three things are being multiplied together and they equal 0. Now the only way that that can happen is either this is equal to 0, this is equal to 0, or this is equal to 0. Now one thing that's kind of unique about this problem is that this one is just 6. There's no x attached to it, which means that number doesn't change. It's constant. If that one doesn't change, well, 6 isn't equal to 0, so that won't ever be the one that equals 0. Now, if that would have been a 6x, then we would have had to consider it, because the x would obviously change the 6. So what we're going to do is we're going to take our two remaining quantities, x plus 3 equals 0, and x minus 4 equals 0, and then we just want to solve. So we will subtract 3, and we'll get x equals a negative 3. And then on the other one, we will add 4, and we'll end up with x equals positive 4. And again, these are our two answers. We are getting two answers to these problems right now. Here's our next one, number 5. In this situation, again, we have our two quantities, and they are being multiplied together to equal 0. So to solve this, just take each of those quantities, 2x plus 10, and set it equal to 0. And then take 3x plus 4 and set it equal to 0. At this point, it's just our job to solve. So we want to subtract 10 from both sides. These two cancel off. We're going to be left with 2x is equal to a negative 10. And then at that point, we just want to divide by 2 and divide by 2, and we find out x is equal to negative 5. Now, as we look at the other problem, we got to get x alone, so we're going to start by subtracting 4 on each side. That's going to leave us with 3x is equal to a negative 4. And then at that point, we're going to divide by 3 and divide by 3. And we'll find out x is equal to a negative 4/3. Now, if you notice, that one's a fraction, and that's okay. When you get to your test, you're going to have to look at it and say, well, did they give me a fraction or did they give me a decimal? If they gave you a decimal, don't be afraid to punch those out to make sure you're picking the right answer. So that's our first set of problems. It's just our solving using the zero product property. Now, again, that's the backbone of everything, so everything kind of builds off of that a little bit, particularly these problems. Now, when they say to factor and solve, what they're basically telling us is you have to do one more step than what you were doing on the last problem, and that is to factor. Now, remember, when we factor, we're looking for the biggest thing we can pull out of each. So in this one, I can pull a 3 out of each of these numbers, and since they both have 1x, I can pull an x out. And if I did that, that would leave me with 1x, right? Because I started with 2x, I took 1 away, and then I would have a minus 6 right here to equal 0. Now at this point, we've created a problem in which this times this is equal to 0, right? And that's kind of the big piece that we want to emphasize. So when this happens, then we just set up a separate equation. 3x equals 0 and 1x minus 6 equals 0, and we just need to solve. Divide by 3, x equals 0. On the other one, add 6, we'll get 1x, which obviously we know is the same as just x, is equal to 6. And those would be our two answers for this problem. Let's look at the next one. Now, number 9 gets a little tricky because everything's not on the same side, right? Remember, we always want to start our factoring process with it equal to 0. So let's pull everything onto the same side. So I'm going to add 2x to both sides so we can start the process. When I do that, I will get 6x squared plus 2x is equal to 0. Now, at this point, once we're equal to 0, then we want to factor. So I can pull a 2x out of both of those terms, and that would of course leave me with a 3x here and a plus 1 here equal to 0. Now we just want to take our two parts that are being multiplied to equal 0 and set them both equal to 0. 2x equals 0 and 3x plus 1 equals 0. Divide by 2, x equals 0 is one of our answers. And then subtract 1 and subtract 1. I'm going to get 3x is equal to negative 1. And then of course I'm going to divide by 3, and we find out x is equal to negative 1/3. Oh, off the screen, sorry. All right, so let's keep rolling along here. So now we get to problem number 11 and 13 and 15, 17, and 19. This is a long one. So in this one also tells us to factor and solve. But what you're going to realize is that there is no greatest common factor here. So in those problems where you don't have a greatest common factor, the other method you always want to try is the x method. So if I tried the x method on this, remember a times c is what's going to give us our top number. So we'll have positive 20 up here. And then positive 9 will go on the bottom. And then we'll have 1x here and 1x here. And then we're just looking for two numbers that multiply to give us positive 20 that are going to add to give us positive 9. And hopefully pretty quick you'll come up with a positive 5 and a positive 4. Once you get those numbers, then we want to write the factored form out. 1x plus 5 and 1x plus 4. Now remember, all of that is equal to 0. So this is equal to 0. Now the nice thing about this is we've created a situation in which this times this is equal to 0. So this is where we want to set up our two equations. So we know 1x is the same as just x, right? So x plus 5 equals 0, and then x plus 4 equals 0 will be the two equations we need to solve. Subtract 5, x is equal to a negative 5. And then on the other one, subtract 4 and subtract 4, x is equal to a negative 4. Nice job. Let's do another one. So this one's a little bit harder to factor because again, we have stuff on both sides. So what you want to do is let's pull everything over to this side. Now, I'm going to have x squared. To pull over the 2x, we're going to have to subtract 2x, so I'll have a minus 2x. And to pull over the 3, I'm going to have to subtract 3, so I'll have a minus 3, and that will be equal to 0. Now we should try to factor this. So coming over here, of course we have a 1 here, so 1 times negative 3 is negative 3. Negative 2 goes on the bottom. We'll have 1x here and 1x here. And then we're just looking for two numbers that multiply to give us negative 3 that are going to add to give us a negative 2. And I think I could get a negative 2. Let's think about this. Two numbers that multiply to be negative 3. So how about a negative 3 and a positive 1? I think that would work for this and also for this. So it looks like we're good. So at that point, remember our factors will be 1x is the same as x, so x minus 3. And then x plus 1. And that's, of course, equal to 0 because that was equal to 0. Now, at this point, what you want to do is just set up your two separate equations. X minus 3 equals 0. X plus 1 equals 0. And now we want to solve. Add 3 to both sides. X equals 3 is one of our answers. take 1 away from both sides, x equals -1. Right, so we're really taking all of our skills in building, but I hope you've noticed the zero product property, right, has really been in every one of these problems. It's just the work we had to do before we got there to start. So we really started with our most basic process, then we made you factor to get to that point, and then we made you factor harder problems to get to that point. We've just been building this up. Now, the last part of this is how we solve using square roots. And this is probably the part about this that is the most unique or the most different from the other method. Now, when we want to solve by using square roots, what we want to do is always get whatever is being squared by itself. Now, once you have it by itself, then what you can do is just take the square root of both sides. Now, the square root and the square cancel each other off, so you're always left with whatever was inside, whatever was being squared. And then the square root of 15, now that's just a number, right? So on my calculator, I can punch that in. Second square root of 15, and I get 3.87. Now, this is the only part that's a little tricky for kids to remember sometimes. You always get 2 answers. Let's even put that on the side. You always get 2 answers. And when you get those 2 answers, remember, one is always the positive version of whatever you were square rooting, and one is the negative version. So in this situation, our other answer, right, since this is coming right from the square root, will be -3.87. That's an 8. And these will be our 2 answers. Now, they're not always like a positive and a negative version of the same number, but whenever you square root, you're always going to get the positive version and the negative that you got to consider. So let's do another one. So in this problem, we have some work to do before we can get the piece that's being squared alone. Now remember, the 3 is not being squared, so we're going to have to get rid of that too. Our first step is going to be to add 43 to both sides. That will get rid of this. That will leave us with 3x squared is equal to 243. Now, we want to get whatever is being squared alone. So we got to get rid of the 3 by dividing. Those 2 go away, and I'll be left with x squared is equal to 243 divided by 3 is just 81. Now, to wrap this problem up, remember, once you get whatever is being squared alone, take the square root of both sides, and don't forget about that second answer. So whatever was inside, x equals the positive version of that number. So the square root of 81, second square root 81 is 9, so there's the positive. And then whatever was inside is equal to the negative version of that number. So this time it's 9 and -9. Let's look at one last version of that problem. So here it is. In this situation, all of this is being squared. So we got to get rid of anything that's not being squared. So what we're going to do is we are going to divide by 4 so that these 2 pieces cancel. Now remember, whatever you do to one side, you have to do to the other. So that's also going to go over there. I'm going to be left with x minus 7 squared is equal to 9. Now at this point, this whole thing is being squared. So to undo squaring it, we want to take the square root of both sides. That means this and this will cancel, and we're just going to be left with x minus 7. Now remember, when we take the square root of both sides, we get those 2 answers. So I'm going to say x minus 7 equals and x minus 7 equals. Set up 2 equations. The square root of 9 is, of course, 3, so we're going to have 3 there, but then don't forget the -3 needs to go on the other one. Now, in the problems we worked before, at this point, we were just done because this x was already alone. But down here, x is not alone at this point, so we're going to have to do a little bit of extra work. So we'll add 7 to both sides, and that will give us x is equal to 10. And then on the other side, when I add 7, these 2, of course, cancel out just like those did. -3 plus 7 is going to give us x equals 4, and that will be our final answer. Thank you guys so much for watching the full video. I hope it was helpful to you. If you do have any questions, though, please make sure you're reaching out and asking. Thanks, guys. Have a nice day.